Hello everyone. Today we will going to see some practice questions from the chapter Organic Compounds Containing Oxygen. This is part 1. Let's start. Disclaimer. The images used in our slide deck are for educational purposes only. We respect the intellectual property rights of original creators and owners of these images. If you are the owner of any images used in this deck and have any concerns or issues, please contact us at sathee@iitk.ac.in and we shall remove the images. We will going to see some practice questions from question number 1 to question number 10. Our first question. Arrange the following compounds in increasing order of boiling point. Propane 1-ol, butane 1-ol, butane 2-ol, pentane 1-ol. So we have given these 4 compounds and we have to arrange them according to their increasing order of boiling point. Options are pentane 1-ol having the most highest boiling point, then butane 1-ol, then butane 2-ol, and then lowest will be of propane 1-ol. Or highest is for pentane 1-ol, then butane 2-ol, then butane 1-ol, then propane 1-ol. Or highest for propane 1-ol, then butane 1-ol, then butane 2-ol, and then pentane 1-ol. Or highest for propane 1-ol, then butane 2-ol, then butane 1-ol, and then pentane 1-ol. You have some time to think about this question. After that, we will see the correct answer. Okay, let's see. So the correct answer for the given question is option A, that is highest for pentane 1-ol, then butane 1-ol, then butane 2-ol, and the lowest boiling point is of propane 1-ol. With the increase in molecular mass, the boiling points also increases. So as the molecular mass of our compound increases, the boiling point also increases. Amongst isomeric alcohols, isomeric alcohol means same molecular formula but different structures. So the given alcohols we have are isomeric alcohols. The boiling points decrease with the branching due to decrease in the surface area. And one thing that with the increase of molecular mass, boiling point also increase. Another thing that if the branching increase or decrease, right, it will also going to affect our boiling points of the compound. So basically, if the branching is increasing, then the surface area will decrease for the compound, and then the boiling point will also decrease. So, and if you see the primary, secondary, and tertiary, from these 3, the primary is having the highest boiling point, the secondary is having the second lowest, and tertiary is having the lowest boiling point among the primary, secondary, and tertiary. Why? Because in the tertiary, the branching increasing, right? Branching is increasing. In the secondary, the branching is increasing, but less than the tertiary one. And in the primary, we have single chain with no branches. So that is why the boiling point is highest for the primary one. Thus, the correct increasing order of the boiling point is highest for pentane 1-ol, then butane 1-ol, then butane 2-ol, and then lowest is for propane 1-ol. So basically, higher the carbon and more the linear R chain will be, the higher the boiling point will be. So pentane 1-ol having, pentane means 5 carbon in it, and it is a single carbon chain, right? Like no branching is present. At the first position, we have OH group, hydroxyl group. In the butane 1-ol, there is 4 number of carbon, and at the first position we have OH group attached, alcohol group attached, right? So from these two, pentane 1-ol obviously is having highest boiling point as the carbon number of carbon is higher in the single chain than the butane 1-ol. And then from the butane 2-ol and butane 1-ol, butane 1-ol is a single chain, butane 2-ol is butanes means 4 number of carbon in our single chain. At the second position we have hydroxyl group. So the position change of the hydroxyl group also affect that, like at the second carbon the OH group is attaching in the butane 2-ol, right? That means one branch, you can consider that one branch is coming. That is why butane 1-ol having highest boiling point than the butane 2-ol. And propane 1-ol, obviously that propane is having 3 number of carbon in it, so that is why propane 1-ol is having the least boiling point from the given alcohols. So the correct order will be pentane 1-ol the highest boiling point, then butane 1-ol, then butane 2-ol, and the least will be for propane 1-ol. And that is why we have our correct answer as option A. Moving on to our next question. From amongst the following alcohols, the one that would react faster with concentrated HCl and anhydrous zinc Cl2S. So from the given options, we have asked that in the options we have given different alcohols. So from the given alcohols, one alcohol that would react fastest. In the fastest means fastest rate or fastest speed with concentrated HCl and anhydrous zinc chloride, ZnCl2. This question have asked in AIEEE 2010. We have options as 2-butanol, 2-methylpropane 2-ol, 2-methylpropanol, or 1-butanol. You have some time to think about this question. After that, we will see the answer. Okay, let's see. So the correct answer for the given question is option B, that is 2-methylpropane 2-ol. The reaction of alcohol with concentrated HCl and anhydrous zinc chloride follow SN1 pathway. So, in the question we have asked that the alcohol is reacting with concentrated HCl and anhydrous zinc Cl2. The fastest alcohol that will react will be. So, the reaction of alcohol with concentrated HCl and anhydrous zinc chloride follow SN1 path 1. Okay, SN1 mechanism. So greater the stability of carbocation formed. In the SN1, we have two-step reaction in which in the first step, we have the formation of carbocation. In the second step, the nucleophile will attack and stabilize the carbocation. Right. So, as the alcohol with concentrated HCl and anhydrous zinc chloride reaction following SN1 pathway, that means the rate will depend upon the formation or the stability of the carbocation formed. So the greater the stability of carbocation formed, faster will be the reaction. So 2-methylpropane 2-ol forms tertiary carbocation. You can see in the diagram. We have C, around which three number of methyl group are attached and one hydroxyl group is attached. Okay. The IUPAC name for this compound is so 1, 2, 3. So 2 methyl propane, because we have a main chain which is CH3 CCH3. At the second position we have OH and CH3 group. So 2 methyl propane 2-ol. Okay, so it forms tertiary carbocation. You can see because OH group is attaching with the carbon which is directly bonded to 3 carbons, right? So this is a tertiary carbocation. Because if you remove this OH group, the positive sign will come at the second position carbon. So this will be a tertiary carbocation. And tertiary carbocation is the stablest, most stablest. Okay, and as we said that SN1 in the SN1 pathway, the rate is depending upon the carbocation stability. So greater stability, faster the reaction, and stability, the stable carbocation is tertiary carbocation. So primary alcohol when react with Lucas reagent, basically concentrated HCl and anhydrous zinc chloride, it will give colorless product And in the secondary alcohol, if secondary alcohol reacts with Lucas reagent, we get turbidity after the 5 minutes of the reaction. Okay. And when the tertiary alcohol reacts with Lucas reagent, we get immediate turbidity. That means immediate product will form. So it reacts rapidly with concentrated HCl and anhydrous zinc chloride. Lucas reagent. Okay, this is a combination of Lucas reagent. Concentrated HCl plus anhydrous zinc chloride is Lucas reagent. So tertiary alcohol react fastest with Lucas reagent, and that is why we have our correct option as option B, that is 2-methyl propane 2-ol, which forms tertiary carbocation, which is the stablest most. Okay, so from the given alcohols from the options, we have one alcohol which is tertiary alcohol, which form tertiary carbocation, which will react faster, which will be 2-methyl propane 2-ol. Okay, let's move on to our next question. Amongst the following alcohols, which would react fastest with concentrated zinc HCl and zinc chloride? So we have this question as that amongst the following alcohols, again we have given some alcohols and you have to tell that which would react fastest with concentrated HCl and zinc chloride combination. This question has came in JEE Mains in the online mode in 2013. Options are pentanol, 2-methylbutanol, 2-pentanol, or 2-methylbutane 2-ol. You have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option D, that is 2-methylbutane 2-ol. Concentrated HCl and zinc chloride is Lucas reagent, and tertiary alcohols having COH group, that means carbon directly bonded to the hydroxyl group, react fastest with it. Okay, so with the Lucas reagent, tertiary alcohol reacts fastest. The structures of the given alcohols are as pentanol, that is primary alcohol. You can see a single chain of 5 carbons containing OH group at the first position. So this is a primary carbon. Because OH group is attaching with the carbon, which is directly attaching only with the single carbon. So it is a primary alcohol. Name is pentanol. Second one we have given is 2-methylbutanol. So you can see that but means 4. So 1, 2, 3, 4. We have 4 carbon in our main chain. And at the second position we have methyl group attached, and the first position OH group attached. This is also a primary alcohol because OH group is attaching to the carbon, which is directly attaching to the single carbon. So again, this is a primary alcohol. Third, we have given as 2-pentanol. In the structure, 5 number of carbon is containing in our main chain, and at the second position we have OH group attached. So this is 2-pentanol. This is a secondary alcohol because OH is attaching to a carbon which is directly attaching with 2 carbons. So this is a secondary alcohol. While in the option D we have a tertiary alcohol named 2-methylbutane 2-ol. Butane means in the main chain we have 4 number of carbons. At the second position we have methyl group, and at the second position only we have a hydroxyl group attached. So this is a tertiary alcohol because OH group is attached to the carbon which is directly attached to 3 carbons. So this is a tertiary alcohol. And as we know that the Lucas reagent react fastest, or tertiary alcohols react fastest with the Lucas reagent. They give immediate turbidity. So that is why the fastest among the options given, the tertiary alcohol, that is 2-methylbutane 2-ol, will react fastest with the concentrated HCl and zinc chloride, that is Lucas reagent. Hence, 2-methylbutane 2-ol reacts fastest with the given reagent, and thus our correct option is option D, that is 2-methyl-butane-2-ol. Moving on to our next question. An unknown alcohol is treated with Lucas reagent to determine whether the alcohol is primary, secondary, or tertiary. Which alcohol reacts fastest and by what mechanism? So we have given that we take an unknown alcohol and we treat it with Lucas reagent. That is considered itself as zinc chloride. Now, to determine that unknown alcohol is either primary, secondary, or tertiary. Okay. Now you have to tell that which alcohol reacts fastest and by what mechanism. This question have been into JEE mains in the online mode in 2013. The options are secondary alcohol by SN1, tertiary alcohol by SN1, secondary alcohol by SN2, or tertiary alcohol by SN2. You have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option B, that is tertiary alcohol by SN1 mechanism. The reaction of alcohols with Lucas reagent occur through the SN1 mechanism. This is confirmed. Okay, so mechanism would be SN1. When Lucas reagent or alcohol react with Lucas reagent, when these two both react together, they follow SN1 mechanism. And the rate of reaction is directly proportional or directly dependent to the stability of carbocation formed in the reaction. So in the reaction, the carbocation formed, the stability of that carbocation is directly related to the rate of the reaction. Stable the carbocation, more stable the carbocation, higher will be the rate of the reaction. Since tertiary alcohols form tertiary carbocation, which is most stable among this tertiary, secondary, and primary, hence the tertiary alcohol will react fastest. Okay, and that is why we have our correct answer as tertiary alcohol by SN1, that is option B. Okay, let's move on to our next question. The product of the reaction given below is, we have given a reactant having cyclohexene ring, and at the fourth position we have our side chain, and we are reacting it in the two steps. In the first step we reacted with NBS and light, and in the second step we reacted with H2 and K2CO3, and we get product X. So we have to tell that what will be the X is. This question has came in JEE Mains 2016. Options are again that cyclohexene ring, but at the third position we have OH group, and fifth position we have that side chain. Or again that cyclohexene, but we have side chain as ketone group, and that side chain alkyl side chain. Or we have again cyclohexene ring, but we have side chain as carboxylic group and alkyl side chain, or only the same as the reactant, that cyclohexene and the alkyl side chain. You have some time to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option A. So we have this reactant here. We reacted with NBS and in presence of light, so we get two free radicals. Okay, so basically free radicals are like there is some charge present at this particular carbon at which dot is represent. So this is wherever this dot is represent, that means it represents free radical. Okay, that means this is a free radical, this is a free radical, this is interconvertible. Okay, now what will happen? The NBS react with it, and the bromine get attached at the position of the free radical. So these two products we will get, and when we react them with H2 and K2CO3, the bromine will be replaced by the OH group, hydroxyl group, and we get these two products. So in the main product, we have cyclohexene ring and the hydroxyl group as a side chain and the alkyl chain as a side chain. Okay, and that is why we have our correct answer as option A. Let's move on to the next question. Rate of dehydration of alcohols follows the order. So when you do the dehydration of alcohols, dehydration means removing of H2 molecule or group. So from the alcohol, the dehydration of alcohol, the rate you have to tell. This question has came in JEE Mains in the online mode in 2013. Options are: highest rate is for secondary alcohol, then primary, then methanol, then lowest for tertiary, or highest for tertiary, then secondary, then primary, then lowest for methanol, or secondary highest rate, then tertiary, then primary, then methanol lowest rate, or highest rate for methanol, then primary, then secondary, and lowest for tertiary. You have some time to think about this question. After that, we will see the answer. Okay, let's see. So the correct answer for the given question is option B, that is highest for the tertiary alcohol, then secondary, then primary, and then lowest for methanol. Dehydration of alcohols refers to the elimination of water molecule, as I said, from the alcohol, leading to the formation of alkenes. When you eliminate the water molecule from the alcohol compound, you will get an alkene. Dehydration of alcohol take place according to Shedjev rule. In acid catalyzed dehydration, formation of most stable carbocation takes place. When you dehydrate the alcohol in the presence of acid as a catalyst, there will be a formation of most stable carbocation. Rate of dehydration is directly related to the stability of carbocation. More stable the carbocation, more the rate of the dehydration. Thus, the order of dehydration of alcohols is highest for the primary because highest for the tertiary because the tertiary carbocation is most stable, then for secondary, then for primary alcohol, and then least for the methanol. Okay, so this is the correct order for the dehydration of alcohols, and thus we have our correct answer as option B. Moving on to our next question. The main product of the following reaction is, we have given a reactant C6H5, CH2, OH, CH3 whole twice. We react it in the presence of concentrated H2SO4. What we will get? The main product. This question has been into AIEEE 2010. Options are an alkene, of course, C6H5, CH, double bond CH, CH3 whole twice, or C6H5, CH2, CH, CH3 whole twice, C6H5, CH, double bond CH, CH3 whole twice, or C6H5, CH2, CH2, CH3, double bond CH2. You have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option A. So we have given this reactant C6H5, CH2, CH, OH, CH, CH3 whole twice. When you react it in the presence of concentrated H2SO4, it will eliminate one molecule of water and it will form a carbocation like C6H5, CH2, CH positive, CH, CH3 whole twice. So the positive sign, the carbocation is at this carbon, and along with that, At the left hand side of that carbocation we have beta carbon, and at the right hand side we have beta prime carbon. Now two things can happen. Loss of beta hydrogen can happen. Beta hydrogen means the beta carbon attaching to the hydrogen, so that is beta hydrogens. So the loss of beta hydrogen will make these two compounds C6H5CH double bond CH3 whole twice. This is a trans, which is major one, and plus C6H5CH double bond CH3 whole twice. This is a cis one. This is a minor one. Okay. And if you loss or if you leave or eliminate the beta prime hydrogen, which is less preferred because the stability of other product is more, because the stability of trans and cis product we get from the loss of beta hydrogen is more. So that is why they will be the main product. But still, if you eliminate the beta prime hydrogen, a compound will form C6H5CH2 CH double bond CH3 whole twice, which is very minor. Okay, so the major product form will be this trans one when you lost the beta hydrogen from the beta carbon. So that is why we have our correct answer as option A. Okay, let's move on to next question. For which of the following molecules significantly mu is not equal to 0? So dipole moment mu is denoted by. So you have to tell that from the first, second, third, and fourth products given, mu will not be equal to 0 for which of the one. Okay, you can see that in the first we have benzene ring attaching to the, and benzene ring and chlorine attaching at the 2 carbon of the benzene ring. In the second structure, benzene ring and cyanide group is attaching at the 2 carbon. Hydroxyl group is attaching with the 2 carbon in the third structure, and the SH group is attaching with the 2 carbons of the benzene ring in the fourth structure. This question has been into JEE Mains 2014. Options are only first and second, only third, or third and fourth. You have some time to think about this question. After that, we will see the answer. Let's see. The correct answer for the given question is option number D, that is third and fourth. In the quinol and thioquinol, quinol is benzene having OH and OH, thioquinol is benzene having SH and SH. So in these two, okay, quinol is OH attaching to the benzene at the 2 carbon, and thioquinol is SH attaching at the 2 carbon in the benzene. So in these two structures, OH groups and SH groups do not cancel their dipole moment as they exist in different conformations. Okay, because their conformation can be different. So OH group and SH group, due to the presence of these two groups, they do not cancel their dipole moment. So you can see that in the benzene ring, when attached in the quinol, when the benzene ring is attaching to the OH and the OH. Okay, oxygen having lone pairs, so their and electronegativity is more compared to hydrogen. So their electronegative, so their dipole moment will be in this direction, and for this oxygen also, the dipole moment will be this direction. So they will add up; they will not cancel out. So that is why their dipole moment will not be equal to 0. And same as in thioquinol, because in the thioquinol also, suppose oxygen, at the place of oxygen we have S. H is same, right? So SH, their dipole moment will also get to add up and not cancel it out. That is why thioquinol will also be will also be having non-zero dipole moment. Okay, that is why we have our correct answer as third and fourth. Let's move on to the next question. Arrange the following compounds first, second, third, and fourth in the order of decreasing acidity. Now, first we have given in which benzene ring is attached to chlorine and hydroxyl group. In the second, we have benzene ring attaching to the hydroxyl group and the methyl group. In the third, we have benzene ring attaching to the hydroxyl group and the nitro group. In the fourth, we have benzene ring attaching to the hydroxyl group and O CH3 group. Okay, so this question has been into JEE mains in the online mode in 2013. Options are that acidity is most for second structure, then fourth, then first, and then third, or most is for first, then second, then third, and fourth, or most is for third, first, second, and fourth, or most is for fourth, then third, then first, and the second. You have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option C, that is most acidity for third, then first, then second, then fourth. So these are our four structures. Okay. The third structure having OH and NO2 group attached to it, the minus M, the minus I effect it will show. While the benzene ring attached to hydroxyl and chlorine show the negative I effect. And the benzene attaching to OH and CH3 group having the plus I in hyperconjugation effect, and the OCH3 and OH group attached to the benzene is having plus M oxidation state. So it will depend on the inductive effect, mesomeric effect shown by these four structures. You can see that chlorine, right? Chlorine is a electron withdrawing group, so it will withdraw the electron from the benzene, increase the acidity. NO2 is also electron withdrawing group. CH3 is electron donating group. OSCH3 is also electron donating, so electron releasing, you can say. So like this, these groups will affect the acidity of the benzene ring and simultaneously of oxygen hydrogen bond. Okay, so if you see at the like chlorine is showing minus I effect, it will you know uh, like has more electronegativity, so it will withdraw the electrons at its side, and the oxygen is having the lone pairs, and that charge will go to the benzene ring and stabilize the benzene ring, but the oxygen hydrogen bond gets polarized, and then easily we can remove the hydrogen bond, so the acidity will get increased. Okay, similarly in the case of NO2, right? So this is the correct order and this is the correct region, mesomeric effect and inductive effect, positive and negative, for the decreasing acidity by showing by these four structures. Electron releasing group decreases, while electron withdrawing group increases the acidic strength by destabilizing and stabilizing the phenoxide ion formed respectively. Right? So that is why we have our correct answer as option C, that is most acidic for third, then first, then second, then fourth. Moving on to our next question. The major product obtained on interaction of phenol with sodium hydroxide and carbon dioxide is. So when you react phenol with sodium NaOH, sodium hydroxide, and carbon dioxide CO2, what will be the major product? Options are benzoic acid, salicylic acid, or phthalic acid. You have some time to think about this question. After that, we will see the answer. Okay, let's see. The correct answer for the given question is option C, that is salicylic acid. Salicylic acid is obtained as a major product by the interaction of phenol with NaOH and CO2 at 400 Kelvin temperature and 4 to 7 atmospheric pressure. This reaction is known as Cole-Base reaction. We have phenol plus CO2 at 400 Kelvin temperature and 4 to 7 atmospheric pressure. It will form benzene having OH group, that is phenol group, and at the ortho position we have CO negative and Na positive. Okay, now the H positive in the presence of acidic medium, we will get salicylic acid. This Cu negative, Na positive will go, and H positive will come here. So it will become salicylic acid, like benzene attaching to hydroxyl and carboxylic groups. Okay, forming salicylic acid. Okay, so when phenol reacts with the sodium hydroxide and carbon dioxide, we will get the major product as salicylic acid under special conditions, that 400 Kelvin should be the temperature and 4 to 7 atmospheric pressure. This is known as Colloid's reaction, a name reaction, and the major product is salicylic acid. Thus, we have our correct answer as option C. Okay, that's all. Thank you.